So for this problem, we're subtracting two rational expressions. That is basically complicated fractions. But it still has to follow the same fraction rule. So of course, if we're going to subtract, we need a common denominator. All right, so in getting that common denominator, you could technically multiply the two denominators by each other. So like you could multiply this whole thing here by x squared minus 2x minus 15. But I will tell you now, that gets real ugly real fast, and we don't need to.
That's true.
Instead, what I always suggest you do with something like this, if the denominators can factor them. And let's hope that they share a common factor, because that's going to make our lives a lot easier. So let's go ahead and do that. On the first fraction, the 5 obviously is not going to factor on the top there. Does the bottom factor?
Yes.
Yes, it does.
Yes.
Notice in this case, it factors by pulling the x out of both terms.
Yep. That's what I see.
Then minus. For the second fraction, obviously on the top, the x plus 5, that won't factor, so it is what it is. On the bottom, x squared minus 2x minus 15, is that a factorable quadratic?
Yep.
Yes, it is.
Absolutely.
Yep. That's going to be x minus 5, x plus 3.
You mean X minus?
No.
Oh, yeah.
All right, so now we got that. Now we look between the two denominators and we can see that they actually do have something in common. They both already have this x plus 3 in them. So I don't need to add that into the other one. But I do need to take this x, and I need that over here. Can I just turn this x minus 5 into an x in any way?
No. Wait, what?
Not really, no. Because sometimes people try to do that. They like try to say, well, what if I add 5 or something like that? No, it's not going to work. The only thing you can do is multiply the bottom by x. And if I multiply the bottom by x, I got to multiply the top also by x. All right, now for the other one. I need this x minus 5 to be represented in this fraction. And again, there's no way I can turn that x into an x minus 5. All I can do is just multiply that x minus 5 into the equation, or into the expression there. So I multiply the x minus 5 in both top and bottom again. And so, go ahead and do that. On the bottom, I'm just going to leave it in factored form. Makes life a bit easier. All right, now I need to subtract them, right?
Yeah.
This is probably going to be easier if we do what? Distribute, yeah. Because I'm going to be actually able to combine some things on the top, I'm going to distribute there. But it's only so I can combine stuff on the top. So you can still leave the bottom in factored form if you want to. If you really want to multiply it out, you can. But it's usually easier if you don't. All right, and so then once we've done that, then let's go ahead and move all this stuff up here so we actually have room to work. All right. When you do the subtraction, be very careful, right? So when we actually combine these top two and you do that subtraction, notice we're doing this 5x here minus this 5x as well. And so that 5x minus 5x goes away. The mistake that I see most commonly is people will do 5x plus 5x. And obviously you can't do that because of the subtraction between them.
That's not real.
All right, so then I end up with negative 25 minus x squared all over x minus 5, x plus 3. All right, now we may or may not be done. We need to check. Does the top now factor?
No, it doesn't. Okay, good. It doesn't.
Oh, nope, it doesn't. If there were a plus here, or if it were a plus here, then we could factor it. But with both of them being negative, no, it does not factor past that. And so then this would be your final answer. That's as good as we can make it. All right, so we end up, in order to be able to do this, multiplying top and bottom by 5 plus 4 root 18. Now, in order to do this, I knew that because this was a minus here, that I needed to have the plus in what I multiplied by. What do we call that when we switch that middle sign?
No, the diff.
So yes, we multiply by the conjugate. And that's worth remembering that it's by the conjugate, because another one of the techniques that we're going to be coming across here pretty soon for dealing with limits is going to be all about multiplying by the conjugate. And so the whole idea is that you multiply by something where that middle sign switches, but everything else is staying the same. All right, so now that we've done that, on the bottom I can go ahead and do that calculation. So let's go ahead and do that part now. And so now, having done that much, it would seem like we're done, but there's actually one more thing we can do. Because you'll notice that this root 18, yeah, we can simplify that down a bit. And so, because the reason is that root 18, remember that equals 3 root 2. Because the square root of 18 is the same thing as the square root of 9 times the square root of 2, so hence why it becomes 3 root 2. So then I do that last step of actually turning it into that. All right, so we get to this point, then we look to see, can this be simplified at all? And in order for us to simplify this any further, I'd have to be able to divide 75, 180, and 263 all by the same number. Doesn't look like it. Nope. And so then, this one's done. And so now we can go ahead and tackle the factoring stuff, which I think was where we had the single biggest area of difficulty. And so we need to be able to factor something that looks like this. Now, the way that I think most of you will have seen how to do this is by the grouping method. And so the grouping method here says the first thing I want to do is I want to multiply my A and C values. In this case, that's 7 and 24. So, break out the calculator. What does 7 times 24 give us?
You don't know?
And so that one ends up giving us 168. So, in order to factor this, the first thing we have to figure out is what two numbers multiply to 168 and add to, notice this is a familiar concept, the middle number still, add to 46.
442.
So, what are those two numbers that multiply to 168 and add to 46? Take a moment, use your calculator, figure out what that combination is, please. And so, it ends up being 4 and 42. The order doesn't matter here. Alright, so what I'm going to do then, the reason why this is called the grouping or regrouping method, is I'm now going to split that 46x into a 4x plus a 42x. And then that's what I'm going to work with. So, I now have 7x squared plus 4x plus 42x plus 24. And what we're going to do is we are going to factor that first pair, those first two terms, factor anything you can out of that, and then factor the second two terms, factor anything you can out of that. So for the first term, let's actually move this stuff so we can actually take a look at this.
Oh, I remember this. And then you do 7 equals 7x plus 4.
Let's see. All right.
Oh, you're right.
And so on that first one, the only thing I can factor out is x. And that leaves me with 7x plus 4. Plus, now I look at the 42x and the 24, and I look to see what can I factor out of both of those. Looks like I can pull a 6 out of both of those. And so that's going to become a 6 times 7x plus 4. Notice what both of those include. 7x plus 4 is in both of those. So basically what I can now do is factor that 7x plus 4 out of both terms. Plus 4 times x plus 6, and there's our factored quadratic. So, when dealing with this, the only way I can simplify it, first of all, let's just be super clear. Remember, you cannot cancel out the x's here because I don't have x's in every term. In order to be able to cancel something out, I'd have to be able to divide it out of everything. And so, my only way to possibly simplify this is to factor both top and bottom. The top is definitely simpler. So let's go ahead and factor the top. And we can use the grouping method here. But when you do that, you should get an answer of 8x and x for our starters. And our last ones end up being 5 and 2.
Oh, yep, that can work.
8 times 2 would give me 16. 5 and x would give me 5. So then I want there to be more negatives than positives. And there's my factored form for the top. Now, what many of you are doing right now
Or you just factor this out.
is you then went on to the bottom, and the first thing you did in dealing with the bottom is you then multiplied 48 and 55 and got a really big number, right? Which, yes, you can do. You can go through it that way. However, remember what the whole problem is that we're looking at here. Remember that the entire goal is to hopefully find something that will cancel out. So I'm kind of hoping that the bottom will either have 8x plus 5 or x minus 2 as a factor. So why don't we check those first and see if either of those can work. I'm going to start with the 8x plus 5, just because 48 and 1 would be pretty big. So let's actually see what would that be. If I actually guess in here 8x plus 5, well, in order to get the 48x squared, I'd have to multiply by 6x. And in order to get the 55, I'd have to multiply by an 11. That would have to be a positive 11 then. So then the question is, does this equal this?
Yes.
I have a question. Wait.
And actually, if we multiply that all out and check it, yes, it does work. And so you can save yourself from having to do a little bit of work when they're in these big fraction problems, because we can expect that something probably will cancel out and actually try those. And so then technically I do cancel those out. The final answer will be x minus 2 over 6x plus 11.